That is example 1. Let's see example 2. We have electrolysis of copper 2 tetraoxide 6 solution using carbon electrodes or platinum electrodes. So we start with mechanism or chemistry of reaction, mechanism of electrolysis, or you call it chemistry of reaction. So there are 3 stages. We consider ionization of copper 2 sulfate. Solution we ionize to copper 2 ion plus SO4 2 minus. Then we consider water. We ionize to hydrogen ion plus OH minus. That's the ionization, followed by migration of ions. So let's see what happened at the cathode. What happened at the cathode? What and what will migrate? So Cu2 plus and hydrogen ion, they migrate to the cathode, where hydrogen copper 2, where copper 2 ion is below hydrogen in the chemical series, is preferentially discharged because it is below hydrogen in the chemical series. That's how the position of ion affects preferential discharge of ion. So when copper discharged in preference to hydrogen ion, so it has lost 2 electrons before, it will now gain 2 electrons, so plus 2 electrons, so to form copper 2, which is deposited at the electrode, and the color is reddish brown. The color is reddish brown. So copper metal is deposited at the cathode. You can see this type of reaction is electron is being gained. That's why we call it rig. Reduction is gain of electron. So at the cathode, reduction occurs at the cathode, while oxidation occurs at the anode. Why is reduction occurring at the cathode? Is because electron is being gained. At the anode, we call it anodic reaction. That is anodic reaction. What happened here? SO4 2 minus and OH minus migrate to the anode, where OH minus, which is below SO4 in the activity series, OH hydroxide ion is preferentially discharged. So we say OH minus electron. I've taught you 4. You put another 4 here to give 2 mole of water plus oxygen gas. That's the equation. So this occurs at the cathode, at the anode. So the gas liberated at the anode is oxygen gas, while copper is being deposited at the cathode. So the remaining solution, contains, it will only remain, we started with copper 2 ion, it will only remain hydrogen ion and SO4 2 minus, because OH has been discharged and copper 2 ion also discharged, so it will remain this and this. So when the two combine, plus SO4 2 minus, you have A2 SO4. So for this reason, the resulting solution contains A2SO4. It is acidic. The resulting solution is acidic. So what we have done in example 2 now, let's put it in a tabular form. Electrolysis of copper 2 sulfate using carbon electrode. I will call this electrolyte. I will call it electrolyte. I will call this, which is copper 2 sulfate solution. That's the electrolyte. So cathode here, what do we use? Anode. You either use platinum, you can use carbon or platinum, you can use carbon or platinum. So what happens at the cathode? At the cathode, we have copper deposition, meaning copper is deposited at the cathode. At the anode, we have oxygen gas is liberated. Gas evolved at the anode is oxygen. So metal deposited is copper deposition. So effects of resulting solution on litmus paper. You can see turning from CSO2 to A2SO4, meaning the result solution is acidic. So it turns from blue to red. The result solution, because it is acidic. So the resulting solution, let's say resulting solution, it is acidic. It contains A2SO4. Is there anything like change in pH? pH after electrolysis, after what happens to pH before and after electrolysis. So the pH, you can see copper 2, this is around 7 neutral. Then the solid solution A2SO4, acid is between 1 to 6. So meaning it has dropped. So we say decrease in pH, meaning you are going to have it to be less than 7. A pH less than 7, it will decrease. Please take note of that. Is there any color change? Let's see color change. Yes. Copper 2 sulfate is blue, from blue to A2SO4 colorless. We change from blue to colorless. This is the summary of electrolysis of copper 2 sulfate using carbon electrodes. Example 3. Electrolysis of acidified water or acidulated water or dilute A2SO4 using platinum electrodes. Electrodes. This experiment is carried out. Take note of this. This experiment is carried out in the laboratory. In the laboratory to determine the volumetric analysis of water, to determine the volumetric composition, volumetric composition of water. Is carried out to determine the volumetric composition of water using an apparatus, called Hoffman's voltameter. Hoffman's voltameter. Call it Hoffman's voltameter. So that is what the apparatus is used to achieve this. So we are going to look at the diagram of Hoffman's voltameter, and from the experiment we discovered that the volume of hydrogen to oxygen gas, the volume of hydrogen to oxygen is 2:1. Please always take note of that. The volume of hydrogen. The diagram of Hoffman's voltameter. It has burette like this, with funnel tube, so we have something like this, something like this. This is a burette closed. This is a burette closed. So this is a burette. This is a funnel tube. Is here you have the platinum connected to a battery. So this is anode, platinum anode. This is platinum cathode. You have the battery plus minus. So So, this is the cathode. This is being filled up with hydrogen gas. This empty space here, we have oxygen gas. And you can see the volume here. The volume here is twice, because it's 2:1. It's always twice the volume of oxygen. This is a voltameter, and this is acidulated water, or acidified water. Meaning water in which small quantity of H2SO4 is added. So, chemistry of reaction, or mechanism of electrolysis. Chemistry of reaction. Let's see the chemistry of reaction. In that voltameter, you use H2SO4 is there. So it will give you hydrogen ion plus SO4 2 minus. Then you consider water to give you hydrogen ion plus OH minus. What happens at the cathode? So let's see cathode. You have hydrogen. So hydrogen is what? Discharged. Is discharged at the cathode. Is discharged at the cathode. How? Hydrogen ion plus electron here, and then balance the equation once and for all to give hydrogen gas. So hydrogen gas is liberated at the cathode. Let's see anodic reaction. What happens at the anode? SO4 2 minus and OH minus, they migrate to the anode, where OH minus is preferentially discharged. Is preferentially discharged. Where OH minus preferentially discharged. Now, OH minus 4 electron, put 4 here, to give 2 mole of water, then plus oxygen. So oxygen is liberated at the anode. And the volume of hydrogen to oxygen is always 2:1. Please take note of. Let's see question. In Hoffman's voltameter, after electrolysis of acidified water, the volume of oxygen obtained at the anode, platinum anode, is 40 cm3. The volume of obtained is 40 cm3. Find the volume of hydrogen liberated at the cathode. The volume of liberated at the cathode. Always remember, volume of hydrogen ratio volume of oxygen, I said, is 2:1. Don't always forget. So volume of hydrogen we don't know. Volume of hydrogen we don't know. The volume of oxygen is given to be 40, is equals to 2:1. So VH all over 40 is equals to 2/1. When you cross multiply, you have VH is equals to 40 times 2. So the answer will be 80 cm3. Please take note of that. Take note of that calculation. So we are done with position of ions in the electrochemical series, where the ion below is preferentially discharged or is discharged in preference to the one above it.